What would you want to do? Or I could do number one. You want this one? Number one? Oh, what? Oh, okay. Oh, so you want to do the homework?
Yes.
Okay, all right. We'll do, here's one goes. Anyway, okay, so I don't mind doing the homework. In which case, if I'm going to do one, I have to do all five. Caveat that there's probably 200 sines and drs and cosines and tangents. I will probably make one or two mistakes. Now, the damnedest thing is, of course, if I make a mistake, the whole thing's wrong. And that's what sucks about this kind of science. But if you can do it, you make 2,000 a year, right? So, now also another problem is I can't check myself. I'm going to have to do this right the first time. You get to check yourself. So I may make a mistake, but just it's sensible, right? Okay, so I don't even remember. I did print out that it's the same. It's what you have. I just printed out what you have to see if I can do it too. Let's see. What is number one? Okay, number one is to figure out to do the kinetic energy. Yeah, to do the kinetic energy deal in cylindrical coordinates, and to write the whole damn thing out, even though it simplifies relatively easy. You wade through a nightmare. That's why this is broken into 5 parts. To get to that relatively simple solution that I wrote down in the last, actually I wrote it down on Wednesday, and it's also part of the question on your problem set, so you see it again. You wade through an unbelievably large number of constants. So anyway, it's just how it is. And again, remember the value is getting you comfortable with this. So I also, other than just increasing your comfort zone, knowing for certain that this just isn't something I picked out of my, what. So, okay. So the way this begins is I will not do this part, the angles, because I actually already did this. I did it twice. I did it at the end of the day Monday, at the beginning on Wednesday when I was a little bit more settled in mind. I kind of started flipping out on Monday. Just that was had a bad week. Okay, but now we need to square this. Okay. And as I alluded to at the end of the day on Wednesday, when I told you that, because I actually do this question every year, that there's no two ways to write this question. All the other questions, especially 7 through 10 on your problem set, those are new. They look like last year's questions, but they're, switch a sine and cosine. There's only one way to ask this. So this is a repeated question every year. So anyway, of course you can look it up on Wikipedia. Now, as I mentioned to you, the problem is one of ordering, because this is why I've been doing this to you. d dx x, d dx 1 over x, blah, blah, blah. I've been doing that because it's not the same as if I permute the x and 1 over x. It is not the same thing. You will not get the same answer. And that's why you've got to be really careful about your FOIL. Okay, so I'm going to start over here. You have to write this out in its entirety. Because when you start simplifying things, and you do have to simplify this to get the expression in the book, you've got to get this in the right order. So notice I put this in front of that. Okay, let's do the next one. I'm going to have a cos CDR. So I'm doing this one, and then sine over r. And then I'm doing, I don't know, inner, outer, I forgot which. Just notice that I'm being very methodical in writing all these out. And of course I'm going to start simplifying it, but I'm not going to write the first expression that way. So this last one ends up being plus So I know it's tempting to write sine theta squared r squared, but no, you can't do that. Okay. Yeah, that sucks. Okay, now to answer several of the questions, this guy can pass through. Right, so the way to get this straight, and maybe I'll have like a miniature version of this on the test, is remember that an operator acts on a wave function. The wave function exists such as to describe whatever is in the Hamiltonian, which is going to have some thetas and some r's in it. Okay, so you got to count on the fact that something's going to be here with some r's and thetas in it. Okay, now this guy cannot be affected by this, so that can pass through. And then I've got 2 change in r, so that ends up being r squared. Okay. That is fortunately about as simple as it gets. Okay, now the same deal with this next one. Cosine, the sine. See, the sine can pass through, but not the 1 over r, right? Because remember, this is like, here's another way I tend to explain it. Operators that are derivatives, smart operators, I call them, smart operators, those are like walls, so we can't, anything with an r doesn't pass. Okay, let's look at this one. All right, notice that this guy here, that these 2 terms are the inner-outer terms. Notice they're not the same. It's not 2 times the same number. And now you can see why. Okay, this guy stays, because there it is. But this, this has an angle and has a derivative with respect to an angle. Notice, see that? See, I can't do anything. There's nothing I can do with it. I cannot simplify it. I just, no. See, told you I'd make a mistake. Okay, so again, sine does not go through. Okay.
Why is sine split?
Where's the sine? What have I done? God, see, told you. I'm going off the cuff too much. Yeah, where did it go, right? I just screwed up. That's where it went. Okay, now I'm paranoid. Right, okay, now I did that right. Thanks for catching that. Okay, that would have been a disaster had I not caught that. Okay, this is where it gets even more unpleasant. There's nothing you can do about this. This is it. Notice how far away it is from the answer, which is just going to be the double derivative with respect to phi. Double derivative with respect to phi. I don't even see that in here, right? That's kind of... Wait, seriously, is that not in here? Well, that's messed up. Look at r squared. Did I do that right? I don't know if I did that right. Oh, anyway. Oh, who cares? Okay. So, how about we do y? Should we do y? Let's do y. Why not? Okay. Now, y, I don't want to go through all the trigonometry, and I gave that to you for a reason, because it was already enough to do all this. And actually, it's slightly easier because everything's positive. Okay, and now I have to square it. And now remember, to wade through all of this is quite a virtue of just being careful, but that's worth a lot. So, same deal. All right, tell you what, let me go ahead and try to do some things in my head, because otherwise this will take forever. Okay, so I already see I've got a sine square double derivative with respect to r. I just did this one and this one. Okay. Now what I need to do is I need to do it the same way I did last one. So I'm going to do this one and this one. So this ends up being, so I can always be certain about the first term. And then cosine is going to come through. And then I've got to change with respect to r. Okay, so again, I did it in my head. Okay, next term, how did I do this one? Okay, this one, cos over r. Okay, this also, I can't do anything about this. Just like last time, this term is the one that's just dead. It's dead to me. Like my stepdad. So, let's see. Let's see, the last term. Let's see, I've got over r squared. Okay. And again, I do have the homework in front of me, so let me see if I've, anyway. Okay, so what I want to do now is combine these two, like I did in your homework. So now I'm adding x squared plus y squared. Okay, because, all right, I've done that, because I can see that this term simplifies. You see how that's going to happen? You can factor out a double derivative of r, so you're left with cosine squared plus sine squared, that's 1. Okay, now, if I recall my own homework set, I'm going to have something cancel out. And then I'm left with 3 terms, and that's what you get 2, 3, and 4 from, something like that. You know, I think it's this term. I think this, and I'm going to permute the sine and cosine to show that, because I can switch these two. It's fine. They're not in front of an operator. Otherwise, I don't know that you could do that. Bam. Okay, canceled. Cancel those out. And this. There's a kind of an odd symmetry to this. Wherever there's a cosine, there's a sine. And actually, wherever there's a one or the other always picks up a minus sign. And yeah, and so anyway, I'll work down from here. God, this is ugly, isn't it? I've already gone off to ugly land. Anyway, like my Tinder. So now what? Anyway, okay. So let me put these two together. I actually don't really even know what that is. I just hear about it, but I don't know what it is. Okay, so let me put these two together. So notice I'm just going to run through all of them in just one swoop. It'll be up to you to figure out which question is 2 and 3 and 4. So I've got sine squared plus cosine squared. Sorry, I did that out of order. Okay. Okay, so I've got the leading term. Remember that this guy actually ends up getting removed. When I said that the r was fixed, this is one of those terms I removed. So, but it is there. Okay, that next guy is gone. Theta over r. If I recall, the way to do this is to simplify the individual terms. I might need to cheat a little bit and just make sure I know what the next step is. Not that I'm looking at the answer, I got to make sure I know which ones I simplify. Okay. Did I do that right? Is that last one cos? Yeah, it's cos. Let's see here. Let me make sure I did get this right. Sine plus cosine r squared. Yeah, okay, I think we're fine. All right, and okay, now on the homework, I've done one of them, by the way, so there you go. Okay, so, let's see, what do I want to do next? Let's see. So the next thing to do is, the way I do this in the problem sets is I actually group these terms together and then I solve them. If I solve them, what I'm going to be able to do is basically compact this guy down quite a bit. And so the way to do that is, and you're going to see this actually done a lot, is I can change this expression and this expression such that I can factor terms. That's the idea. Now the way to do that is, it is extremely not obvious what to do at this point. I see nothing that's factorable. The answer is to act on it with a wave function. Now, so, if you really were a good mathematician, you could kind of just see that on your own, but I'm not. So what I do is I see what the operators do, and I do that by operating on a wave function. I don't ever say what the wave function is. I just give it a generic little psi r, psi phi. Okay, so let's do this one. And again, what I'm going to do is give it something to work on. Okay. So, let's see, I'm going to have minus sign. Something will happen with this at the end. You can see actually the derivative of the r. The derivative of this guy happens, and there's nothing else to do. So it can get shuffled all the way to the left. Okay, now where this gets funky is this SOB right here. Cos wave function. This is the part where it gets hairy. Okay, so again, these are done. These are done. And now I've got to, you see how I'm going to factor some stuff, because I'm going to pick up some terms, and I bet those terms are either going to cancel between. You see, I'm actually doing just this one, and then I'm going to do that one, and because I'm going to pick up terms from a cross product, I'm going to get some things canceling, leaving behind something that like factors into something smaller. Okay, the derivative of cosine is minus sine, in which case the wave function stays on its own. Then cosine stays on its own, and then I end up with the derivative of the wave function. Okay, and yeah, that's something, isn't it? Is that? Yeah, I think that's what you're supposed to do. Man, did I really assign this to you? This is awful. Okay, so that's, what is that? That's part, and actually I'm already on number 4, by the way, apparently. Let's do this one. Next turn. And I am not smart enough to do this in my head. I've got to do this, I got to do it the longhand way. Let's see. I will, there's enough symmetry. There's enough symmetry in the problems that I'm going to end up with the wave function with respect to r, just the derivative of it. I'm going to get that again. Okay, so it's kind of similar. This happens, and then it's done. And then I've got the same deal. I've got the derivative of an angle of two things. So I've got a product rule. Okay, so this ends up being cos r. Again, nothing happens with this. So, that's kind of funny because they're not, I don't see these canceling, so I'm already a little off here. Not that I'm off, I just don't see it yet. Okay, then this derivative of sine is cosine. Wave function sticks around. Then sine sticks around. Then I got the derivative. Okay. Let's see here. I will just keep working down because I'm not seeing it. Now I promise it does. Actually, I give you the answer so I can see where I'm going with this. Okay, so anyway, so if I get totally lost, so actually I can sum these two because I'm doing the two. The first box I know I did them one to the left and one to the right, but actually you can sum every line. And I didn't do that on purpose, but I'm glad I did, because it actually makes sense. Okay. Yeah. You see what's going to happen? Sine squared, cosine squared. See that? Okay, I'm starting to see how it's going to simplify. Okay, so I'm going to multiply it by the terms now. Sine, and I forgot the angle. So I'm just doing the first term. Okay, now I'm sine squared. Okay. Let me go over and do this one. So remember, all of these are added together. Sorry, I am obviously a little wacky today. I'm always wacky on a Friday. Let's see, then I got cosine squared over r. Here we go. Okay, I just did two terms, so I've got two more to go. Minus. I gotta be more careful. I just took care of that minus, but then that subtracted. And no, what the hell's wrong with me? That's this term. Sorry. Okay, so now let me do this one and this one, which is so there's no more operators, by the way. It's nothing you got to keep track of. There's no more operations. I've already done them. So I can just start writing stuff down. I just want to group it in a way that I don't get lost. And then I've got just the double derivative. Well, I'm double derivative. The derivative with respect to every one of the SOBs, R and C. Okay, so that's that term, and now let's do the last term, which is this one to this one. Again, I'm going to try to make sure I write them out in a certain way. I'm kind of switching how I'm doing this to be symmetric. Look at that. Yeah, look at that. What is shocking to me, by the way, is I totally thought I was going to blow this, and so far I haven't, which is ridiculous. All right, you see? You see? Cancel. Am I crazy? This canceled. Yeah. Okay. Oh, it gets better. No. Okay, now I'm a little lost. Okay, I've gotten rid of this. This is awesome. What the heck do I do with this? I'm going to factor out. No, you know what? I can't. I'm making a mistake here. I'm making a stupid mistake. So here's another lesson here. You actually have to be really careful how you write these out. Okay. So what I was about to do, this part here, I was about to write it on the left and not the right. Okay. Let's see if this is right. Okay. Yes. Now, why was that important? This ends up being 1 over R. Okay, is this right? Yeah. Okay, so those middle terms, the ones in the box, have turned into this mess here. Now here's the thing, this is a bit tricky. Now you've got to undo what you did in terms of adding the wave functions. Remember, we're trying to get an operator, not the operator of a wave function. Because to be blunt, I'm actually going to do more manipulations later. I've manipulated all the manipulations I can manipulate, so I can't manipulate it anymore. So I have to undo what I did. I have to figure out what this is in an operator language as though I'd never operated on it. Okay, what that is an operator language is this. I'm just making sure I do it right. That's what this is. Okay, because again, multiply this by wave function R, wave function phi, then it turns into this. All right, you see how I did that? Operate on the wave functions, you turn into that. So I'm kind of reverse engineering it. Okay, so I hate to write over my own stuff, but if we're going to make any headway, I have to do that. And I will actually end with a little bit of time. Where's that? So I've got this gone. Oh, I can't believe this is working. This is nuts. Okay, so I've got that guy gone, and all of this mess turned into... So this guy was easy. I didn't have to operate on a wave function. There you go. Ta-da! Now I gotta do this guy. Let's do that. I think that's number 5. Because I've got to get my double angle, my double derivative with respect to phi. I haven't found it yet. Now again, if you follow along with what I'm doing, which is kind of shocking even by my standards, is that, yeah, so I do it the same way. So I'm not looking at the answer key, by the way, I'm just looking at, yeah, so to simplify this, we have to do the same trick. We have to operate on it, time some wave functions and see what happens, and untangle it. And what I better get, I believe I better get 1 over R squared, double derivative with respect to phi. All right, so I got to get that. Okay, let me kind of do it this way, because I'm going to have to do the wave functions. See how I had to give myself some space here. I'll probably not, I'll leave this term, the one I'm writing down now, I'll leave this alone and just do the one on the left first. So same trick. Let me give myself some more room here because I see I already need it. Because this, product rule, it tends to cause it to branch out. And, okay, so already I can, there's no R wall. Okay, so that means that I can already get the R wave function. I can pass it through. And that means that this jazz, well, yeah, I'm looking at it. There's no derivative with respect to R. Okay, so that makes, yeah, okay. So that this guy is the only thing that can go through. Now this is truly, you see why I saved this one last. I've got the derivative of a derivative See that? Now I remember having my mind blown at this when I was your age and I saw this. It's good. All this is a product rule, but one of the products is a double derivative. That's where this is going to turn into. So I didn't actually need to give myself so much room. Same deal. So I actually can do this. So I can do the right-hand one. It's yeah, it's not that bad. And I can already tell that I'm probably going to end up with a sine squared, cosine squared. Okay, so that this is visible. Okay. Oh, look. Yeah, I'm totally going to end up with the sine squared. And I'm going to end up with the cosine squared. So something's going to turn into the number 1, or subtract maybe. I don't know. Let's see. Sine over r squared divided by r. Looks like I'm going to need to go to the other board. Okay, let me. Derivative of the sine is cosine, right? And then I leave this alone. Then I've got the double derivative. Oh, actually I did need that room, didn't I? Okay. I hope my handwriting isn't too terrible. Okay, product rule, derivative of cosine is minus sine. Another thing to always be wary of, that you don't think that I'm subtracting. It's times a minus, right? That throws me off sometimes. Again, I cannot actually literally make a mistake. That's why I'm kind of in your state of panic. Okay, then the function as is, double derivative. Parenthesis. Okay, and let me keep working down. Is that what I did? Oh yeah, that's what I did here. That's what I did here. Okay, so let's just wipe all this out. Okay. I thought for some reason, I thought I had finished that first guy on single board. I obviously didn't. And, another big thing here is, folks, if I can do this, PhD and all, sure I do, but it does show you it can be done. And that's, part of the, remember I was telling you the story of my advisor. That's what that guy did for me. Okay, so now what I'm going to do is I'm doing this term, and then I'm going to add this one, because I can already see that they cancel. And I am going to reorder, because there's no more operations. That's another thing. I've seen folks, I'm just reordering. I'm multiplying these two and I'm reordering them because I want it to match this. Of course it does, it needs to be correct. Hopefully it's correct. Okay, is it correct? All right, now this guy just wrote out like normal. Again, since I've already done all the derivatives, I can reorder them however I want. So I took care of the sine, cosine, r, and now this is that, this is that, this is that, this is that. They cancel. Okay. Plus sine squared over r squared, double derivative. Plus last term cosine squared over oh look at that, look at that. It didn't matter. I just forgot to square it. I just dropped the 2, so that was not too bad. It's not too bad. Double derivative, so I'm just not keeping, just trying not to lose track. Okay, and what did I What did I drop? I dropped something. I knew I dropped something. Sorry about that, following your notes. Now, again, I can't emphasize this enough. You do have to, when I'm, all right, so my point here is that when I factor this, I've got to be really careful how I do it. Whether I pick one on the left or right, in this case it actually does matter, because I got to set myself up to untangle the operations from the wave function. Okay, so there's not much else to do here. When again, if I now have to work backward, if I now work backward to what the operators are, I can tell that, let me go back up here, I can see that there is no derivative with respect to R. That guy does get to stick around. Only the wave functions need to disappear. And that's it. Give me some money. Oh, you already did. There you go. I did half your homework. So, next one. Oh, come on, I'm on a roll. Huh? Kind of painful? Now, remember in class, when I said, when I turned this into the kinetic energy operator, when we did fixed R, there actually is no wave function with respect to R, or there is, but it's a constant. So those will go away, and that's why this ended up being minus h bar squared over 2I, double derivative. That's why the Hamiltonian actually reduces in cylindrical coordinates to this very simple expression. Okay, so tell you what, folks, I got one more. Want to see one more? What? Yes? No? Huh? How about one more? Okay, so yeah, let me show you one that's coming up. One's coming up, so you haven't seen it yet, but we're going to get to this next week. Because it's another example of this manipulation. Yeah, you should definitely see this. I may not get a chance to do this again, and now hopefully you're getting it, right? How this works. Okay, let me show you this. All right, I just showed you how those R's come out of the cylindrical coordinates. If you do spherical, not that we are, and I'm not going to do it in an extra hour or anything like that. When you do X, Y, and Z, you get this. It actually doesn't look that much, it actually looks kind of the same. It actually looks kind of the same. Anyway, you just saw me write all this down just a minute ago. I just eliminated all the R's. And again, when we do hydrogen atom, we can't do that. And I would say actually maybe don't even write this down because we have plenty of time to do it again Monday and Wednesday. Okay, so this is the 3D guy. I just did it in class. I actually just limited it to this part. But these are the radial parts. Now, as it turns out, when you solve these miniature Schrodinger equations, it turns out that we're going to have R, theta, and phi for the Schrodinger equation. The theta and phi will not have energy in it. They don't determine energy. The R miniature Schrodinger equation actually has energy in it. And so when we solve that miniature one, that actually dictates the energy. So, so that's why solving these R bits is actually going to be kind of horribly important. So I just wanted to show you, because we got 5 minutes left. Let me do something. We can manipulate these to make them easier than all this mess, and let me just show you that. And the reason I'm doing this is because, so all of this is actually this. That's the point. So I can take this, which will prove to be very difficult to work with, and I can turn it into this. And hopefully you know that the way, based on what I just did, you do it the same way. You operate on it, let it do what it's going to do, and then untangle it. Okay, that's the idea. So what I end up with is r squared plus, I like doing derivatives of derivatives. It just kind of reminds me of how this stuff works. Okay, so then I've got myself a product rule, 2r derivative with respect to r. Then I leave r squared alone and do a second derivative. Okay, what this ends up being is 2 over r, and I'm going to go ahead and untangle the action of the wave functions. Double derivative. All right, see what I did? So again, I operate on a wave function, do all the product rules. That's what it comes down to, doing product rules. And then I just remind myself, what would the operator be if I never did it to begin with? And look at that. This is here, and this is here. So these are the same thing. Okay, now again, the reason to do that is that in this representation, things are much, much, much easier to solve than the way that we get when we just solve for the angles. Let me do one more. Let me do one more of this. I'm going to leave this here because this is the one we actually work with. See, there's actually 2 of these. And we are actually going to work with this representation. Where am I? This one. So I don't know how they figured this stuff out. Okay, this. This is also this. Now how do I know that? Again, let's operate on the wave function. Okay, I've got a product rule. I do the first derivative. I got myself a product rule. Then I've got to do the thing again. Then I am going to do the first derivative of this one, and then I'll leave that r alone and then do the double derivative. And this ends up being, look at that, I've got 2 of these terms, 2 over r, derivative with respect to r, plus double derivative. Okay. Which is, again, the same as that. Okay, so all of these are the same operator. So now again, the point of this is when we do the hydrogen atom, the radial is the most important one. But solving this in the way that pops out of dx squared plus dy squared plus dz squared, solving it in this form is horrible. We're actually going to do it in this form, but they're the same thing. And there's other problems that will actually use this form. We use whatever's convenient. So anyway, that's coming up next week. But the main thing is that, just to make it a little bit more meaningful, on the exam, typical a derivation is one of these. Not one of these, but one like this, where I ask you to show one operation's equivalent to another, and you do it by the method I just showed. Operate on the wave function, do its thing, untangle it. Just to make sure, I'll put a couple on a homework so that you get exactly how to do this.